Hi, in this tutorial I'm going to register a number of images and then show you quickly how I go about checking the accuracy of the registration. So for this purpose I'm going to use again the images that are distributed with ATRA under example 1. So we have 4 images here. Quickly I will create the image list file that is required as an input to ATRA. So let's just look at the image list files. It's simply a list of the 4 images in a text file. Then I can start running ATRA, and as input -I image list is given, and I'm going to put it in the verbose mode using the -v command option. And let's just, for the heck of it, make the output images right anterior superior orientation. So we let the program run. For checking the accuracy of registration, I use the itksnap software. The itksnap software is very useful for this purpose, and I highly recommend it for you to download it if you don't already have it for this purpose. So we let the program finish. So it's done. It took 36 seconds. Now since I use the RAS orientation as the output, I will have a bunch of images called V1, 2, 3, or 4 underscore RAS dot NII, as you can see here. So these are my post-registration images. These images are supposed to be aligned. So the purpose now is to manually check quickly to see whether they are indeed aligned or not. So I'm going to open V1 and V4 using itksnap and then compare them. So first I'm going to open V1 for display. So itksnap v1 ras.nii, that is first image. Next I'm going to open the second image, v4 ras, or actually the fourth image. So the nice thing about itksnap is that once you open multiple windows, they're sort of locked together, and if you click on a voxel in one image, you will see the corresponding voxel on the other image. So that is what's nice about itksnap. Okay, so I can zoom in and click on some points and see the corresponding point on the right. So this is the AC. I'm clicking on the PC so I can see that. So you can click on different points and verify that you will see the same point on the other image. So I can tell that these images are very well aligned. I can tell you that these images are from a patient with dementia, and V1 was taken at a baseline time point, and V4 was acquired roughly 8 months later. So while these images are very well aligned, as far as I can tell, there are also some differences in these images. And actually, the purpose of registering these images is to be able to detect the differences that would not be otherwise obvious. So, for example, let's look at the um, let's look at the axial images, and let's move to the superior orientation. So you can see, for example, over here, you can see that the crosshairs are at the sort of the roof of the lateral ventricles, and you can see on the image on the left, uh, the ventricles are smaller than on the image on the right. So in 8 months, there has been considerable expansion of the ventricle at this point. You could also look at the hippocampus here. So the hippocampus also there seems to have undergone some subtle atrophy uh, during these 8 months. So this is what's really exciting about uh, being able to register the images across time, and then either visually, but even more interestingly, using computer algorithms to detect the changes that occur in time and determine whether these changes are a normal part of aging, for example, or there is pathological aging.